Hey everyone, and welcome to Dev Days 2020. I'm here to cover business intelligence and talk about how you can go from charting to data experiences in Google Cloud. You could think of this a little bit as a business intelligence 101 for Google Cloud. Here's a look at our agenda for today. Now, before we get too far, I want to take an opportunity to introduce myself. My name is Shane Glass. I'm a developer advocate covering business intelligence here at Google Cloud. So that's a little bit of everything from data warehousing and BigQuery to data experiences in Looker. So let's start with an introduction, and I want to take a look at the common BI workflows. To me, there are three of them. The first one is charting. Charting creates one-off static visualizations that are intended for a non-repeated analysis. Usually this is done to help someone better understand or quickly understand a spreadsheet of data they were just given in a visual format. Now, the second is dashboarding. Dashboarding creates repeatable, slightly scalable series of visualizations for sharing with a wider audience than charting. Dashboarding can help address a broader series of questions than charting can, but it does have some limitations in the amount of granularity and detail that can be provided. And the final one is data experiences. Now, data experiences assure people and systems get delivered to them in a way that makes the most sense for their needs. Data experiences can represent any number of ways in which companies derive value from their data. This could be reducing costs and mitigating risk, or adding value by increasing revenues and optimizing spend. It could even be external economic value by monetizing data and creating new value streams. Now, the state of enterprise workflow today, how we conduct these business intelligence workflows is, in a word, inefficient. It's inconsistent. BI tools that aren't built for modern cloud-based architectures require you to extract data to refresh it. This means you aren't always looking at the same data as everyone else if you didn't refresh at the same interval. It also means that business units across the enterprise can have the different definition of the same metric depending on how they extract it or how they work with it after extraction. This can make comparing performance across business units sort of like comparing apples to kumquats because of this inconsistency. It can also be inconclusive. Charting and dashboarding can only provide so much information, especially if they can't incorporate real-time data. This means that decision makers don't always have the context they need to properly interpret the data they're given, leaving them with an inconclusive view of the business. Now, how does this happen? Well, it's partially because of the current state and tools that we use in enterprise BI. Things like spreadsheets, data governance with siloed warehouses, desktop-based BI tools that require extractions of data, and manually sharing reports as opposed to being able to share a web-based tool that gives you the live look. This means a frustration for a number of people. The first is the data analyst. They're developing and analyzing data, but it becomes more frustrating because you can't easily share the results of the analysis. It kind of begins to feel like a fruitless effort since your work isn't getting to the people and places it needs to. For designers, this means that they have to work within the limitations of the available tooling, keeping in mind that their tools might not be the same as the tools on adjacent teams. This can add significant work and time to the design process. Executives have to juggle multiple data warehouses and multiple dashboards from different places, which means that the same metric might be measured in different places with different results. The data engineer has to work with the combined limitations of multiple data warehouses and multiple BI tools. This makes their work significantly more difficult and can often create challenges that wouldn't otherwise exist. Your security teams are now spending their time managing data access and user access across multiple tools and warehouses. Or even worse, they aren't able to manage access to the things they need at all. And finally, the business leaders. Ultimately, they end up with inconclusive results, which means they don't have the insights and information they need to run the business. Plus, they spend more of their time managing the process as opposed to utilizing it. But the good news is this is fixable. Don't worry, we can fix this. It doesn't have to be this way. Google Cloud offers a suite of BI tools that can help you move from inconsistent, inconclusive reporting to performant, comprehensive outcomes. We can leverage modern BI tools that are designed to take advantage of the power of BigQuery and other data warehouses to get the performance benefits of a cloud-based data warehouse. This means you can analyze all of your data in real time without sacrificing the performance of your BI tools. We can find a suite of tools that are comprehensive and fit for purpose that allow you to generate the reports you need with as little complication as possible. This helps you get the comprehensive answers you need and not the frustration you don't need. And how do your customers, internal and external, feel about it? Well, the data analysts are able to more easily share their analysis and the underlying assumptions. This means fewer calls, emails, and chats to explain the analysis, and more time analyzing data. As a data analyst, I can tell you, that's definitely what we prefer. Designers are working with cloud-based tooling, which means that everyone has access to the same tools, and designers can focus on meeting the business needs instead of trying to work around limitations. Executives can make apples-to-apples comparisons instead of apples to kumquats for key metrics from different business units, because everyone has the same definition of the metrics. Your data engineers can now develop pipelines that meet the needs of teams and scale to provide more throughput when needed without unnecessarily using resources when they're not. Your security team has one place to manage data and user access controls. This means fewer headaches for them, and more importantly, less risk of inappropriate data access. And finally, the CXO, the decision makers. Fewer data governance headaches and a more streamlined reporting process means that they can spend more time determining what the analysis means instead of managing and worrying about the process to get there. So, how can we transform the current state of enterprise BI to this promised land that I've described? Well, let's take a look at what that would look like for each of our individual use cases. We'll start with charting. Let's take a look at who would be charting or what I mean when I say that. Generally speaking, it's someone looking for a quick answer to a question. It's probably a question that isn't repeated very often, or maybe they just need a quick visualization for a report, or maybe even just a sanity check on a data extract. For this, I'd recommend Google Sheets with connections to BigQuery. Connected Sheets empowers you to work with billions of rows of data in the familiarity of the spreadsheet you're used to. And, of course, you get the familiar shareability and the collaboration that comes with Google Drive. It helps unlock your big data easily. SQL knowledge, now optional. Use the familiarity of spreadsheets to pivot, filter, chart, and develop formula analysis. It also has secure collaboration to boost data-driven decision-making and collaboration while still controlling who gets to view and share and edit the data. Let's start by taking a look at a demo of this. We'll start by using the City of San Francisco's 311 or non-emergency maintenance requests. I'll use this demo throughout the rest of the talk, so let's give a brief overview of the 311 requests first. This is the non-emergency maintenance requests that come into the city for everything from graffiti to trash removal. This is a great proxy data set available in our BigQuery Public Datasets program that can help customers build dashboards that are similar to the types of requests they would get from their customers or service requests. So as you can see here, we're already connected to BigQuery, and we have about 4.3 million rows imported. You can refresh this manually, or you can have it refresh on a schedule. We can also break out by custom queries, which we've done over here. And what you see here is the count of all service requests broken up by their category. So let's start by creating a chart here. So we see it load, and we'll come up here and insert our chart into our new sheet. This will take a moment to create, but once it does, it brings over a relatively familiar interface, similar to other BI tools. You'll see over here the possible dimensions and measures. We can change our chart type, stacking options, and sort and filter. We'll drop our categories onto the x-axis and the number of service requests onto the y-axis, or the series. We'll click Apply, and we'll see our chart load here in just a moment. It's as simple as that. I'll come down here and I can sort or filter the dataset as I need to. Maybe you want to sort by most number of requests. Maybe you want to sort alphabetically. Those options are available here for you. But as you can see, we were able to visualize millions of rows of results quickly and easily in a way that's familiar to everybody. So let's go back to the slides and let's take a look at our second use case, dashboarding. So much like we did with charting, who's doing dashboarding? This is probably a team of analysts, each of whom need to make a decision based on multiple factors, which require context from either a single data source or multiple data sources to provide the entire picture. It could also be an individual helping provide a means to explore data for a limited group of stakeholders. But in this scenario, dashboarding probably requires us to manually manage the permissions, so we don't want this group to get too big. For this, I'd recommend using Google's Data Studio. Data Studio is Google Cloud's free modern BI tool, which only requires a Google account to get started. It's simple but powerful to use and has connectors built out to hundreds of different data sources. It enables real-time collaboration with the familiar interface of Google Drive, and you can build engaging reports and dashboards. Data Studio also includes a gallery of pre-built results that you can copy and make your own without having to start from scratch. The hundreds of connectors built into Data Studio allow you to connect, analyze, visualize, and share your data simply and easily, again, without having to start from scratch. I'd also like to touch on BigQuery BI Engine here as well. BI Engine is a blazing fast in-memory analysis service for BigQuery that allows users to analyze complex data sets interactively with sub-second query response time and high concurrency. The BigQuery BI Engine seamlessly integrates with Data Studio and Google Sheets to significantly accelerate data exploration and analysis. This is coming to other tools in the near future too. So I want to take a look at a dashboarding demo, and I actually want to walk you through a code lab that we have built that'll give you this demo. It'll be available to you after the talk ends. So once this code lab is complete, your dashboard should look something like this. Again, we're using the City of San Francisco's 311 requests, but this time we've grouped by neighborhoods to allow us to filter and sort by each neighborhood to see where we need to prioritize our efforts. But first, let's go back to the code lab. So we have a brief introduction here that gives you another overview of what Data Studio is and what you're going to build, along with a pretty picture of what the end's going to look like. It gives you kind of the overview of what you'll learn and what you'll need to get started. Keep in mind that SQL knowledge is helpful, but not required, but you are going to want a basic understanding of data visualization best practices. So to get started, you'll access the BigQuery public data sets. This is where the San Francisco 311 data is stored, along with 311 requests from the cities of Austin and New York City. It's one of more than 150 available datasets in the BigQuery Public Datasets program. You can see here the link to the available datasets in the catalog that'll help you find other datasets like weather datasets, demographic, or geographic boundaries that might be useful for other analyses. And again, a reminder that the 311 data, while a good proxy for customer service requests, maybe not perfect. If you haven't already, go in and set up your Google Cloud project. And if you'd like, you can set up your resources in a separate project and go ahead and delete once you're done with the code lab. Next, we'll connect our Data Studio and BigQuery instances. We'll start by creating a data source. You'll see once you enter Data Studio and the reports page, we'll start by clicking on Create a Template. So we'll click Blank Report under Start with a Template here. From there, be sure to accept the marketing practices as they pop up, and then click Save. In the Add a Report window, which will look like this, view the Connect to Data section and select BigQuery by clicking BigQuery. You'll authorize, you'll add a billing project and the project for the public data sets, and click over to the service requests. At some point, once you're done with that, your table will look something like this. You'll have a blank report. I'll go ahead and walk through that process so you can see what it looks like. I'll click BigQuery. And now I'll come down here to public data sets. Keep in mind that the billing project you enter will be billed for any queries you run against the public data sets in BigQuery at the normal billing rate. We'll click Public Datasets, and then we'll manually enter our billing project. Now keep in mind, this will be different for each individual project. I can search from the public datasets, and I'll search for San Francisco 311. And from here, I'll select the table I want and add to report. Okay, now once your data is connected, you'll come up here to the Resources tab, and you'll click Manage Added Data Sources. From here, you can see the data sources that are connected to your report. By clicking Edit, you can make changes to the field types. Now, Data Studio does its best to make the understanding as best it can, but sometimes we want to make different changes. So for instance, I've changed the neighborhood center to represent a latitude and longitude type so that we can use it for a mapping visualization. Once that's done, you've connected your data to Data Studio, and you're ready to get started creating your visualizations. Now, Data Studio will start your report by adding a table up here in the top left. Go ahead and delete that though, so that we can get started on ours. So first, we'll add a tree map like we see down here in the bottom left of the completed dashboard. To add that, you could simply click Add Chart and then Tree Map at the bottom. You can click and drag and drop it onto the screen to determine the size. Next, we'll come over on the right-hand side, and we'll add category to the dimensions and the count of service requests. This allows us to see at a visual level what requests are most common in the category. And you can see it's by far street cleaning and sidewalk cleaning requests, followed closely by graffiti and encampments. Come over here and you can make some minor styling changes as detailed in the code lab. Once it's done, your dashboard will look something like this, with just the tree map in the bottom left. So let's keep going. We'll start by adding the map visualization, which you can see here, to your dashboard next. For this, we'll use the location and neighborhood center that we talked about earlier. We'll start by adding the neighborhood center to the bubble location to tell it where on the map it should put it, and the tooltip to give us the name of the neighborhood as we look at it, along with the number of service requests. The number of service requests will determine the bubble size. So this helps us see the number of requests that are submitted by neighborhood. Now, once it's completed, your dashboard will look something like this. Okay, we're getting there. Now we'll add the scorecards that you see across the top left. Now, you might want to visualize the number of requests you get for the most common types. To do that, you come to Add a Chart and Add Scorecard. You can either add with or without compact numbers. For our purposes, let's add without compact numbers. You can see on the left-hand side that we'll add the metrics for the sum of the type of service requests, and we'll add a filter, as described in the code lab, that only counts those categorized as street and sidewalk cleaning requests. We'll do the same thing for graffiti and encampments with different filters. So once that's done, We'll add a little text to the dashboard to make it more understandable, and your dashboard will look something like this. But we're not quite done yet. Let's add a filter. Now there are 4 different filters in Data Studio: chart level, group level, page level, and report level. For our purposes, we'll add a page level filter up here in the top right, and we'll give it the neighborhood dimension so that our users can filter by the neighborhood they want to see. You'll want to group all of your charts together or make it page level so that they interact with each other. This way, when users view your dashboard, they'll simply be able to come down here, select a given neighborhood, and all of these metrics will update for that neighborhood. So for instance, in Potrero Hill, you can see that in the last 3 years, we had almost 17,000 street and sidewalk cleaning requests. We could see there were 5,279 graffiti requests and 5,284 encampments. And you can see the location and relative bubble size. By coming back up here and selecting all of our neighborhoods, you can see how that compares to the larger picture. Now, I mentioned that Data Studio is easy to share and collaborate in real time with, and that's perfect. It's exactly what we want to do. We'll give our dashboard a name that's familiar and easily findable, and we'll share it using the button up here in the top right. Check out some additional code labs by searching for Data Studio, and keep an eye out for future code labs that explore Google Cloud's newest BI tool, Looker. Let's explore our final use case, data experiences. We've opened each of these use cases by exploring who would be analyzing or who would be conducting these use cases. But in this, for proper data experiences, it's all of the personas that we talked about at the beginning of the talk. It's the data analysts who need to monitor internal metrics. It's the designers who need to develop dashboard solutions for clients, internal and external. It's the executives who need to visualize and quickly understand data insights. It's the data engineers who need to be able to build scalable and effective pipelines. The CXO who needs to improve governance and data reporting. And the security folks who need to maintain appropriate security controls. All of these teams are involved in a proper data experience. Now, for building data experiences, of course, I recommend Looker, one of the newest members of the Google Cloud family. It's our cloud-native enterprise BI platform that enables secure access to near real-time data when and where you need it. It enables modern BI and analytics, integrated insights, data-driven workflows, and custom applications, all of which is powered by Looker's platform and its unique architecture. The in-database architecture involves no additional data movement or storage by pushing the queries back down to the data warehouse. It gives access to all the underlying data, not aggregates, not cubes, not extracts. And it leverages BigQuery's native functionality, including BigQuery GIS, user-defined functions, and BigQuery machine learning. Now, the real power, in my opinion, of Looker is the semantic modeling layer, LookML. It defines standard business logic across the entire business. It has robust data permissions that are available at the row level, column level, or content, and can even be dynamically changed based on a user's role. And it has Git integration in the IDE for proper versioning control. And most importantly, it's cloud native. It's 100% web-based with API extensibility, including an API for BigQuery. This helps you build unlimited data experiences. Now, Looker's platform offers a unified surface to access the truest, most up-to-date versions of a company's data. With this unified view into the business, you can choose or design data experiences that assure people and systems get delivered the right data in a way they need it and that makes sense for their needs. I mentioned earlier that a data experience can represent any number of ways in which a company gets value from their data. Some examples include reducing costs and risk by improving workflows, adding value by increasing revenues or optimizing spend based on performance. You can even use this to monetize your data and generate new value streams for your customers. And we should note that these experiences aren't just limited to internal users. In fact, many customers use Looker to deliver compelling and dynamic experiences for their customers and partners as well. As a unified single system, Looker is architected in a way that separates the data layer from the consumption layer. And what this really means is that you can deliver data in any way that you want. In fact, Looker's solution for BI offers huge value for customers by providing data governance at scale. You can define metrics and tie different data sets together to create a full view of the data that describes your business. This allows you to create a single definition of metrics and data no matter where it comes from, any siloed database. It empowers users to self-serve. You can create interactive dashboards and reports that inspire users to drill down and answer the next question they might have. By delivering real-time governed data where users need it, it allows any decision to be data-based. Looker also supports repeatable, flexible analysis that doesn't require a data analyst to write custom SQL for every analysis. This allows them to collaborate and codify their understanding of the data within Looker's flexible version-controlled modeling layer called LookML. Through Looker, users can now work with the metrics on their own, freeing up data teams to work on more high-impact problems and projects. And finally, it allows you to operationalize your data in an effective, innovative way that drives efficiency and growth. You can support your internal customers and external customers with timely, trusted insights and automated operational workflows that lets your teams focus on what matters most. Now, the magic of Looker is being able to deliver data experiences beyond BI. While being a single unified system, this helps you get as creative as possible about how you want the data anyone inside and outside your company to see. By integrating insights into the tools you're already using, by supercharging operational workflows with complete near real-time data, or by building out entirely custom data products that deliver complete experiences far outside traditional data analytics boundaries. Now, that sounds like a lot. Let's take a look at the demos to see what we can work with. And again, we'll visualize the San Francisco 311 data that we last saw. So we'll load our Looker dashboard here, and we can see right off the bat that it is significantly more interactive than what we were able to get in either Data Studio or Google Sheets. And this is the power of a true, full data experience. Now I can come down here and I can define custom boundaries using any of these maps. And I can see out here key metrics that have been defined in Looker's LookML layer, which we'll examine in a minute. But the real power of Looker as a data experience is it allows me to drill down further into my data and see. For instance, this tab shows me all of the unclosed requests that have been opened in the last 3 years. I can see that there are 24,418 of them. But what if I wanted to take a look at each of these on an individual layer? If I wanted to take a look at the table or an additional dashboard? Well, the good news is Looker allows you to do that with its drill down functionality. For instance, I can see here that there is a table that's created that shows me all of the important information from the data that backs this tile. Now I don't have to trust that the aggregation is real. I can see that for myself. So let's come down here and filter by any value. In this case, we've chosen to filter by neighborhood, and we'll filter by the same neighborhood, Potrero Hill. So now I'll select this, and it'll update all the metrics when I click the refresh button. Now I can come down here, and I can see the results that are specific to this neighborhood that I'm examining. Maybe you could think of this as a regional sector that one group oversees. This dashboard could be developed at the enterprise level and shared with all employees that are managing these requests. Now I can come down here and I can see more detailed, including weekly trends on the number of open cases, the complaints by service type and category, and where these complaints are occurring. I can even see new requests, requests that have been closed, and requests that remain open, a closure rate, and how long it takes me to close these. Now that I filter by neighborhood, I can come back up and I can see the requests that were open in this neighborhood for the last 2 years that still remain unclosed. This allows me to see if there's a pattern and potentially take action from this tab. Okay, now let's take a look at the magic behind this, the LookML. This is the semantic modeling layer that Looker uses to provide single defined metrics for all users. You can see here, it looks similar to what we expect to see from a JSON file. We've already defined the table elsewhere, but I've come down here and said, just give me everything from this. And I can tell it what do I want it to define, including the measures and dimensions and how I want them to be defined. I can customize these based on SQL. I can customize permission using Liquid SQL for user roles, and I can define my drill down fields like I did earlier. All I have to do is come down here and say, here are the fields I want to see when I drill into it. And I come up here and say, this is the metric I want to click on to see it. The flexibility of LookML allows you to define a single semantic layer over your data, no matter how many places it comes from. This allows all of your users to see the same data with the same definition and the same metrics. Think of how much time that could save. All right, well, thanks for joining me this afternoon to talk about BI and Google Cloud. If you're interested in learning more, I recommend checking out Data Studio's website, available here on the screen, or the Looker page as well. As promised, we'll leave time to get to the Q&As, but in the meantime, thank you for your time.